So here's an example of a problem that you might see on the third interview, which covers work, energy, and momentum. And you can see the relevant equations are shared here down the left side. So this says that an elevator moves down a distance of 10 meters. There's a tension from the cable pointing upward, shown on the diagram. How would you figure out the elevator's change in velocity during this motion? So I would say, well, first of all, I recognize this as a work and energy problem. And I'm going to be able to answer the change in velocity by looking at the kinetic energy, which is defined in equation 3 and relates to the velocity of the object. Okay, so in any of these problems, you're going to if you have work and energy or momentum, you'll need to define your system. So here, my system, you have options. I'm going to take my system to be just the elevator, right? So I'm going to say if my system is just the elevator, then there's going to be an upward external force of tension that's shown and a downward force of gravity. Okay, so I'm going to use equation 2 to say that the net external work on the system gives me a change in energy, and the only energy that my system could have would be a kinetic energy. Because it's just a single object, I'm not dealing with potential energy. So I would say, well, the total work, the displacement is downward, right? So I could use equation 1, which basically says, in this case, the work done by the tension points up while the displacement is downward, so that's going to be a negative work. And then the work done by gravity is going to be positive because gravity points downward in the same direction as the displacement. So I would add those two together, and that would give me the change in kinetic energy. Right? And then if you don't answer this, I might follow up and say, okay, well, how would you tell based on that whether the change in velocity was positive, negative, or zero? And so I'd say, well, okay, whatever the external work, if the external work is positive, then the change in kinetic energy is going to be positive, which means it's speeding up, right? So if that were the case, that would mean that the work done by gravity is bigger than is bigger in magnitude than the work done by the force of tension. So that would be the case if it were speeding up. If it were slowing down, then the work done by the tension would be the greater than the work done by gravity. All right, so that's it. Now the other option would be to say, well, I want to define a potential energy due to gravity, so I would take my system to be the elevator and the earth. And then I would still have to say that there's still an external work from the force of tension, right? So that external work is negative. So I know that since there's a negative external work, the total energy of my system is decreasing. But I wouldn't be able to answer from that whether the kinetic energy change is positive or negative, because I'd also have to calculate the change in gravitational potential energy. So I'd use equation 4 for that, and you can see that depends on the change in height of the elevator. Right? And so none of the other equations 5 through 7 come into play at all. Right? There's no spring involved, and 6 and 7 are for momentum problems, which you'll have a momentum problem if there's a collision involved. All right, so either of those two approaches would be fine as a way of explaining this problem, whether you want to use potential energy or not. The one thing that wouldn't be acceptable would be to say, well, to find a net force and use Newton's law, second law, to figure out the acceleration and calculate the change in velocity that way, because that's kinematics and forces. That's a different unit. Now, in principle, you could do it, right? But it's not what I'm looking for in this unit. I want you to use energy work and momentum to answer these questions.